In this episode, we cross the bridge from assembly, that means electricity, into C. This video contains the complete and the exact code for the also the broken down line by line. We aren't just writing the software; it means we are building the infrastructure for reality. In this episode, we start from the module 1 to the module 3, and in our module 1 our target to write like 0xb800 is hardwire to complete the graphics card. We are physically muting the state of the GPU's memory wire. We start to write this code in src folder at kernel. It means we start the writing our kernel. This is our first file of the kernel, which is a vj.c. We will import the library of vj.h and static const size t num column, which is equal to 80, and static const size t nums row, which is equal to 25. It means we can define the physical constraint of the hardware text mode. First is 80 columns wide and 25 rows tall. Then we write the struct vj char and uint 8 underscore t character uint color. Okay, it is for the fundamental this vj character is the fundamental unit of the reality for the screen. Every pixel matrix on the monitor maps back to the exact 16-bit layout. It means 8 bits for the ASCII character and 8 bits for the color. Here is 8 bit for the character, ASCII character, and 8 bit for the colors. And static struct vj character all const vga buffer means struct vj character all 0xb800. It means the portal we cast the raw physical hardware address into a pointer of our struct type. It means writing the array instantly changes the screen. Then static size underscore t column, which is equal to 0, and static size t, which is row, equal to 0, and static u int 8 and color, which is equal to 0x87. It means the 0x07. It means the light gray on black, light gray on black. Then we can write the for screen clearing functions void vga clear for we will use the for loop for this and initialize the size t from I equal to 0 to I less than number of column into the number of rows. in between this number of column and number of rows, and I will increment by 1. Okay, and VGA buffer from I to the struct VGA character dot character, it means it can backspace or and dot color equal to color. In between this and here is a column which is equal to 0 and row which is equal to 0. In basically our line 1 we define the function which is a VGA clear, and inside the for loop iterates overall 2000 cells, it means 18 into 25 on the screen. Okay, then VGA buffer, we override the whatever garbage memory is currently on the screen with a empty space. We define as a dot character, and our default background color which will define, it is a 0x07, it means light gray on a black, and column 0 and row 0, it means we reset our state machine cursor back to the top left corner of the monitor. Then we start to write the another function, static void, which is a print new line. Here are define the column equal to 0. It means if here is a conditional, if row is less than number of column, number of rows. If row is less than number of row, what actually we define here is number of column and number of row 80 and 25, number of row is the 25 minus 1 and row plus 1. We check that what exactly is writing, and inside this we use the else. If row is less than number of rows minus 1, then increment by 1, and else attaching the for loop size t equal to c 0, row equal to 1 and r is less than number of rows, r increment by plus 1. Another for loop inside the for loop, it means it is a nested for loop, size t c which is equal to 0, it means column for start from 0 to c is number less than number of the columns, and increment by c plus 1. And then VGA buffer, which will r minus 1 and num column here is the VGA buffer row into a num column plus c. Okay, exactly we write this, and then exit of the for loop. Here is for loop, this for loop will end on this, inside this another for loop which can start from the size t c which is equal to 0 and c is less than num columns and start c plus plus, we increment by 1, and VGA buffer which is number of columns number of rows minus 1 and number of columns plus C. It will our struct VJ character start from dot character to the this and dot color to the color. It means this is the basically a hardware, this print new line is a basically hardware emulation. This monitor does not automatically scroll down when you hit the bottom. When we hit the basically model bottom, this monitor does not automatically scroll down. And then in line 3 where we initialize, it means our if row is less than num, it means if we are at the bottom, we must physically copy the every single pixel from row 2 up to the row 1 and row 3 to the row 2, etc. And there is a clear after here is a basically clear. After copying everything up, we wipe the very bottom row clean, so new text can be written there. And here is a print character. It means handle a single keystroke. And if character is the enter key, they trigger our new line emulation and stop. We will write for this void VGA print, which can print and taking as an input const character address, and for loop from size t I equal to 0 to str I is not equal to zero and I plus 1. And print the character character. It means if character is the enter key, trigger our new line emulation and stop. Print character. We need to add the another function, to the most important function. Then takes the standard C string and iterate through it until it hits the null terminate and print it the character by character. In this basically, if our cursor has hit the right edge of the screen and force a new line grab, the math row, it means row into number of columns plus column flats our 2D coordinate system. After this code, there will be the header file will create and .h. They basically take the brings in our VJ powers and scale out static const character and label string, which is equal to the, and start from the debug and then info. What exactly this, we will check that. And it can basically, this is a label string. It is an array of the string prefixes. By standardizing our tags and our logs become a searchable and a parsable. Okay, it may debug, info, and warn an error. Okay, we will start to write another static log level t. It means klog minimum level which is equal to 1. It means 1 which is equal to the info. It can write the void klog function having the arguments log level t level, then constant character which is a module, then const character which is a message, and if there is a conditional, if level is less than klog minimum level, then return not anything, and vj print level string which is a level, vj print, and then vj print module, vj print and vj print or message, vj print enter or backslash n. It means next line. It means there is a line 1 and 2 which can basically brings our vj power, and then line 4 to 9 which can the level of the strings. It means an array of the strings prefixes by standardize our tags, our logs, and become searchable and parsable. And here is a line 11 which is the klog minimum level. It is the global state variable. If system is running perfectly, we don't want to see the debug spam. We set the gatekeeper to the info. And here is a line 13 and 14, 13 and 14, basically a klog set level. Klog set level, it's the functions that allow us to dynamically write this function. Void klog set level. There is a log level underscore t and level. It means it can set klog min level which is equal to level, and this is basically function. It can allow us to dynamically change our noisy OS at the runtime. And where is the line 17, it means our klog, the core API takes the severity, the subsystem name which is a module, and the message. And line 18, it means the conditional, if the level is less than minimum level, the gatekeeper, if the message is the debug but we are set to info, instantly drop the message to save CPU cycle. And line 20 to 25, when we stack the string together using the VJ driver, it outputs in a highly structured format like the info kernel system booting, like that. We will save this file. There is a file klog.c and vj.c. Inside this file we need to add the main file which is the main.c. It can call the both library. First vj.c another is a klog.h, vj.h, klog.h, and void kmain can basically unsign long magic and unsign long adder. Inside this, first we will write wipe the environment clean. Wipe the environment clean. So VGA clear, we'll call the clear function VJ clear and establish observability. Observability. It will call the klog dot set level 1. That means set to the info. Then next, third is a announce reality. What exactly the announce reality? It means klog giving the arguments 1 kernel and start OS is waking up. And then klog 1 dot boot means from transition to the 64-bit C kernel is successful. Okay, and then verify the bootloader integrity. So if magic which is equal to, there is an address 0x3 6D76289, check that what exactly this address, we will check it. So klog 1 dot boot to the multi boot 2 magic number is verified. Else the klog invalid multi-boot magic number. And VGA print the system initialize and while eternal orchestrator it means while one the ASM the volatile halt. We will check exactly what is in line 4. There is a kmin which can see enter the CPU, the CPU enter here, and the magic password left by group, and the adder is the physical memory location of the hardware map. We will use in also in episode 4. And the here is a VJ clear which can destroy the old assembly VJ marker, which is the 1 2 3 to the and reset the cursor. And here is the Kellogg set level which can set the info, it means turn on our flight recorder at the info level. And Kellogg which can turn on using our new abstraction to speak to the user. And kernel OS is waking up, then transition to the 64-bit to the 64-bit C kernel is successful. And then if magic, which is the address number, we double check the reality. If bootloader is the corrupted the state, we throw an error, log immediately. And while one, the kernel never returns. If it did it will execute the garbage memory and crash. It will the garbage memory and crash. We wrap it in an infinite loop. The halt instruction tells the hardware turn off the CPU processing unit to the save memory and do not wake up until the hardware interrupt occurs. This is the resetting heartbeat of the system. Okay. With that, then we will see in our next episode.